In this video series, we are going to talk about scanning tunneling microscopy. Why tunneling? Because of the quantum tunneling effect that is the underlying basis for this instrument. I guess you all can relate to that. All of you got at some point in your life an electric shock in the moment of touching something. And that is what happens in a scanning tunneling microscope as well. You have the sample and you bring the tip of the probe very close to the surface. At a certain distance, electrons overcome the energy barrier between sample and tip and start tunneling. The resulting current can be measured and contains information about the sample topography. But what is this tunneling effect? Do you know the German fairy tale The Frog Prince? In the fairy tale, a young princess drops a golden ball into a pond, and a frog offers to help her to get it out again if they become friends. Since the princess knows that there is no other way to get the ball out of the pond, she accepts the offer of the frog. Now, the plot of the fairy tale would have been very different if it played in the nano world and the golden ball was an electron. Then it would say, the princess dropped the golden electron ball into the pond, but thanks to the tunneling effect, it dropped out again and they lived happily ever after. The difference is the following. The golden ball does not follow the rules of quantum mechanics. The golden electron ball, however, does. And there it says that golden electron balls are never in a single point location. They only have a certain probability of being in that point. Now, although for the golden electron ball the probability might be maximum at the ground of the pond, there's also probability that the golden electron ball is at the top of the pond, right there where the princess can grab it. And that is the tunneling effect. A particle, that's the golden electron ball, that actually has too less energy to cross an energy barrier, which is the pond, crosses the energy barrier anyway. Now let's take a look at STM again and let us see what it means. You bring the tip of the STM close to the sample and you would expect nothing to happen, because there is an energy barrier that must be crossed. But thanks to quantum mechanics and the tunneling effect, some electrons from the sample cross that energy barrier anyway, and you can measure a small tunneling current. The tunneling current is very sensitive, and slightest changes in the distance between tip and sample will result in a change of the tunneling current. If there is a topographical elevation on the surface, this can be registered by an increase in the tunneling current. By scanning the sample, a two-dimensional image can be generated. And that was a short introduction about the principle of scanning tunneling microscopy. I hope you enjoyed it, and I see you in the next video. Thanks for watching.